Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about what are the different types of data and then different types of sampling techniques. So when it comes to the type of data, so already you know that, so the data is going to be of different types, so variables and then constants. So again, this variable is going to be divided into further categories like qualitative and then quantitative data. So that means qualitative data and quantitative data. So again, this qualitative data should be of different types like discrete, continuous. So quantitative means where we can able to measure the data, whereas qualitative means where the data is not going to be measured. So example like height in centimeters and then weight in kgs like this. So the data what is going to be measured, so that should be in the form of measurements. So whereas the qualitative data, it should not be have any kind of measurements. Suppose color, so color means red, blue and then green like this. So these are the different classifications of the data. Okay, so the data should be of different types like variable and then constants. So once I'm going to consider this variable, so again have to be consider this qualitative and then quantitative data. So qualitative data means, so these are the data where we don't have any kind of measurements. So where quantitative data means where you can able to consider the measurements. So again, this quantitative means where you can able to further divide it like discrete and then continuous. So discrete data and then continuous data. So the continuous data maybe depends on time. With respect to time, the data is going to be changed. So whereas the discrete data, it should not be depends on the time, right? So before that, so data is nothing but is a fact, or it may be an observations, or it may be information, so that can be collected for reference for analysis, so which is going to be used as a basis for decision making. And variable means any characteristics with the changes which value, and then constant means a characteristic which does not changes the value or nature. So the data may be that, so it should be a fact, or it may be an observation, or it may be an information, so that may be collected together for reference or analysis, which should be serves as the basis for the decision making. And variable means, so any characteristics which changes its value, so that should be the variable. And that means height, weight, sex, martial status, eye color. So these are some of the examples of the variables, and these variables should be classified into two types like qualitative and then quantitative. When it comes to the constant here, so the characteristics which does not have the changes its value or nature, so that should be treated as a constant here. Example, the height of person, so after the 25 years of age. And qualitative data, so qualitative data means it should be non-numerical data, so that can be arranged into categories. And this data is also be called as the categorical data. So other synonym that one I can able to call it as the qualitative data as the categorical data also. So this data does not have any numerical data that is going to be arranged into categories. So example like a gender of the individuals and nationality of the player and grade in examination. So if I'm considering this grade in examination, so it may be A plus A, B minus B like this, and nationality of player means Indian, American, and then Italian like this. So these are not the values, right? And gender of individuals like male, female like this. So this and all should be the qualitative data. And quantitative data means that, so it should be a numerical data that consists of counts and measurements. So quantitative data means that, so it should be in the form of counts, or it should be in the form of measurement. So example, the weight of the person, examination marks, profit of salesman. So these are the different types of data here. So mainly the quantitative data means where is going to have some measurements here. So like weight of the person. So weight of the person I can able to measure in kgs, and examination marks like So how much it should be, like 970, 80, like this. And the profit of the salesman, so how much dollars is going to be get, some $100 like this. So this and all will be the quantitative data. So normally this quantitative data is going to be further classified like discrete and continuous, what I said earlier. So discrete data means that it should be able to take only the finite or countable number of values. So normally this should be the usually whole numbers. There should not be any floating point values you are going to be considered here. So that means here the only the finite values are going to consider. And so examples like the population of the country, like some 100 millions, and the number of cases of certain diseases like 10, and the number of students in the class 60, like this. So these and all should be the countable values, and at the time it should be a whole number also. Continuous data means it should able to take all the possible values in certain range, and thus have an infinite number of values as well. So that means it does not contain any gaps or breaks or jumps in between them. So the continuous means here we can able to take the possible values in certain range, and which is going to have an infinite number of values also. So normally this data does not contain any kind of breaks, grabs, and then jumps as well. So like suppose height of the person, so suppose the height of the person, if I'm consider, so it may be some 5 centimeters in 1 year, and the second year is grown up, and then it should be not 5 centimeters and 5 meters assume, and then 5.5 like this, and next after 1 year it should be 5.7. So the height is going on increasing by every year. So and temperature of certain place, so the temperature at 9 o'clock it should be some uh, 30 degrees centigrade, and 10 o'clock it should be 32 and degrees centigrade, and then 11 o'clock it should be 35 degrees centigrade, like this. So all this height of the person, here, the data is going to be changed continuously, so with respect to the time, so that should be considered continuous data, and this should not be uh, the data is not going to be changed with respect to time. So that should be the discrete data. So here the variables can be classified based on its scales of measurement, and Stephen SS is going to be introduce some 4 types of scales of measurement, like nominal, ordinal, interval, and ratio scale. And so there are 2 types of scales of measurement that should be comes for the category variables like nominal, ordinals, and other 2 scales that should be come from quantitative data, that should be intervals and then ratio scale. So scales will be of 4 types, so nominal and ordinal and interval and ratio scale. So the first 2 should be reflected to the qualitative data, and second 2 should be reflect to the quantitative data. Okay, so these are the some of the different types of data. So normal types of scales or types of scales also is going to be measured, and like a nominal and ordinal. So these 2 kinds of measurements will be reflected to the qualitative data, and then intervals and ratio scale is going to be reflected with the quantitative data. So what is the nominal scale here? So nominal scale means that it should consist of 2 or more named categories where the objects are going to be classified, and the data at this level cannot be ordered in the meaningful way. Okay, so examples like classification of individual using the blood group, and then classification of individual using the sex, caste, and the nationality. So these are the some of the examples of nominal scale. Okay, so it should be consist of 2 or more categories where the object is going to be classified, and at the same time the data at this level can be ordered in the meaningful way. So example, classification of individual based on the group. So if I'm going to have some groups of people, so the blood group of this person should be B minus, A B minus, B plus, B plus, and B plus. So here the classification is to be done based on the blood group. So like uh, B plus blood group people will be this, and then A, and then B minus. So this, like this, the classification is going to be classified in some particular order where the data cannot be ordered in some meaningful way. So that thing should be considered as the nominal one. So the classification of individual using the blood group is another example. And classification of individual using the caste and then nationality also another example of this nominal scale. An ordinal scale means that so it should be similar to the nominal scale, but how the data is at this level can be ordered in a meaningful way. So, but the differences between the data values either cannot be determined or it should be meaningless. So, so ordinal scales also similar. Some things look similar to the nominal scale, but the data at this level cannot be ordered in the meaningful way. So, but here the differences should be between the data values, and that can be determined or it should be meaningless. So, examples is that so the groups of individuals according to the income, such as poor, rich, and class. So, groups of students according to the grades in the examination, fail, second class, first class, and then distinction. So, ordinal scale means here we are going to measure some order here. So, rank, so first, second, and third, and then grade. So fail, and then first, second, distinction. So here I'm going to order some fashion of the data order, right? So that should be considered as the ordinal one, right? So these and all some of the examples of this ordinal data, where the group of people is going to be specified some particular order. And scales of measurement, suppose if I'm going to consider the interval scale and ratio scale. So the data from the interval scale can be a ranked order and has a sensible spacing of observations such that the differences between the measurements are going to be meaningful. And then interval scales should be the lack of great ability to calculate the ratio between the numbers on the scale, but there is no true 0 point. So that means the temperature on Fahrenheit and then Celsius scale. So this interval scale means that so the data which is from can be a rank order, and then there should be a sensible spacing of observation such that the differences between the measurements are going to be meaningful. And the interval scales means where the lack of ability to calculate the ratios between the numbers on the scale, but there is no 0 point. And the ratio scales mean that so the data on ratio include all the features of interval scale and in addition to the true 0 point, and therefore accurately indicate the ratio between the two spaces of the measurement scale. So it should be the best example of measurements and used in almost all places. So ratio scale means so it should be the best example scale of measurement and it should be used in almost all the places. So example, monthly income, height in centimeters, and weight in kgs. So ratio scales is somewhat different to the interval scale. So but so here in addition to the true 0 point is going to be constant. So and therefore they accurately indicate the ratio between the spaces of measurement scale. So it is the best scale of measurement and is going to be used in almost all the applications or almost all the places. So some of the examples already I told should be monthly income, height in centimeters, weight in kg. And so collection of data. So once you know the type of the data, so what are the ways we are going to be collecting the data? So there should be of two ways of collecting the data. So primary and secondary one. So the primary data means that so it should be the original data which should be collected by the investigator or him or himself or herself for a specific purpose. And this kind of data generally should be fresh and should be collected for the first time. And the data can be collected by the below methods like observation method, interview method, survey method, and questioning method. So the data should be primary one, so that should be originally gathered by the investigator himself or herself for the specific purpose. And this kind of data mainly for the fresh and the first time here. And the data what I'm going to be collected should be done through the following methods like observation method. So by observing the by doing the experiments I can making observation I can able to extract the values, and by conducting the interview method by asking the questions, and then survey method and then questioning method. So these are the main methods that is going to be applied for the primary data. So example like population census and then data collected by the researcher for his project, everything should be that primary data. And when it comes to the secondary data, so the data what I'm collected should be done by someone else or prior to or the purpose of the current project. And this should be processed and the finished data. And secondary data is the data that is going to be reused, and it involves the less cost, time, and effort. And examples may be the data that I'm going to be collected from office records. So already existing data is there, so that one I'm collecting, so this should be the secondary data. And then reports which are already collected by some other agency, so and then the data available on the internet, and the data from books, and the data from magazines. So all this all already available one, so that from that I'm going to be considered the data. So they should be treated as the secondary data. So previous thing is the primary data, that means that this is the data which is conducted for the first time itself. For obtaining this, where that should not be available in anywhere of the facility. Then next one is that data sampling. So what is the data sampling here? So sampling is nothing but a statistical technique, so which is going to be obtained uh, from the representation of the population, so that the inferences which is going to be based on the sample is going to be considered. So why are going to do sampling means that, so this is not possible whenever every item in the population is going to be measured, and then it is difficult to be measured in infinite population. And when the results are needed urgently, and when the area of the study is wide, and then when the elements get destroyed under the investigation. So these are the some of the reasons, so in order to conduct the sampling here, that means, so it should be that statistical technique of obtaining the sampling of the data from the population. And so when it comes to benefits of the samplation, so samplation is going to be reduce the process time, and so the results that can be obtained quickly, so due to the time saved in the data collection and then further analysis. So this reducing the time is one of the best advantage of the data sampling. And it should also be reduce the expenses that are incurred in the collection of data. So normally in order to collect the data we are going to have different methods like primary and then secondary, and here there should be some of the methods and there should be some of the methods are available. So in order to implement all these methods, definitely we can able to incur some expenses on these methods. So due to this sampling, this type of expenses also is going to be reduced here, and so makes that the sampling should be economical. And due to the reduced volume of work, and data collection and analysis can be completely efficiently during the using the well trained staff and then sophisticated machinery. So this should also be increase the accuracy of the results. So this is the another advantage here. So sampling is the one of the best way, so which is going to be reduce the time and then volume of work, and then should also be should also be reduce the expenses that are incurred in the collection of data. So normally the key concept that is going to be used in sampling should be that is sampling units, that means the members or elements of the population, and sampling size means where the number of units in a sample, and sampling frame means that it should be a list of all the members or elements of the sampling. So sampling units means the members of elements population, And sampling size means the number of units in sample, and then sampling frame, it should be the list of all the elements of members of the population. So types of sampling, so normally it should be simple random sample, stratified random sample, and then systematic sampling, and then cluster sampling. So like this, the sampling is going to be measured in different ways, like a simple random sample, stratified random sample, systematic sampling, and then cluster sampling. So when it comes to the simple data sampling, so normally the sampling is going to be conducted without the replacement, so it should be more convenient and should also give more precise results. And simple sampling is effective, so if the population is going to be homogeneous and the population has no differential sections or classes. So random sampling should be the simple and effective one. So whenever the population is going to be homogeneous and they should not be have any differentiated sections or classes. And so normally this one is going to be done without replacement, and it should be also be more convenient, and it should also give more precise results. So example, so in order to conduct this socio-economic survey of a particular village, so we can randomly select a sample of families, and then we can also find the per capita income of the village. So this is the one of the view of this simple data sampling. So here is the population. So this is one of the sample of this population, and this is also one of the sample of this population. And stratified data sampling. In this method, and the entire population is going to be divided into different non-overlapping homogeneous groups called as strata, and then a simple random sample of a suitable size is selected from each stratum to form a sample. Normally, this strata is going to be divided based on some criterion like such as geographic location, age, gender, religion, or income. So normally the population is there. So from this population, a non-overlapping homogeneous groups, it should be considered as the strata, and the simple random sample of the suitable size is going to be selected from the sample. Normally this strata is going to be divided, so based on some criterion like geographic location, and then age, and then gender, and then religion or income, like this. So example, so in order to estimate the annual income per family, so I can able to divide the family population into homogeneous groups such as the families with the yearly income 50,000, and between 15,000 to 1 lakh, and 1 lakh to 1.5 lakhs. So this should be used the stratified random sampling here. So this is the view of this stratified data sampling. So if I'm going to consider the population, so the population is going to be divided in some groups, so based on some particular characteristic, and the sample of what I'm taking from each stratum should be considered as a sample here, and this should also be considered as a sample like this. So systematic data sampling means, so this is the another way of data sampling. So here the method is going to be involve the selection of elements from ordering the sampling frame. So that means if I'm going to have a population, though, then the way of selecting the population in a systematic order. Suppose if I'm going to consider the second element of the population sample. So this is 1, 2, 3, 4. So 2, 4, 6, 8, 10, and 12. I'm going to select some particular order of sampling. So that should be considered as a systematic sampling. So the methods involved in selection of elements should be considered as a sampling frame. So in order to draw the systematic sample of size n, so the sampling units are going to be numbered from 1 to n, where n should be the population size, and we are going to calculate the sample interval. So that means capital N by small n, where n should be the population and should be the small size. and there should be a systematic sample of sizes which is going to be include j plus k and j plus 2k observations. So only the first unit at the random going to be determines the entire sample. So systematic data sampling is the one of the well ordered data sampling. So here we can able to select the sample sizes, so and then we're going to calculate the sampling interval as well, and we can able to say select the data elements so based on some positions. Suppose if I'm going to have a committee of n students that is going to be selected from the class of n number of students. So to draw this as a systematic sample size of n size n, so the students are going to be numbered from 1 to 60 using their roll numbers. So then calculate the sample interval. So actual 60 by 60, 60 by 6, then it should be 10. So select a random number in between 1 to 10. That means if I'm going to consider 3 or 4 or 5, suppose if 5 is going to be selected, then I have to consider the fifth element of the sample of the population. So like this, if I'm going to have up to some n number of students I have, suppose, so I am going to collect 5 is the number. So next 5 plus 5, 10, 15, and then 20, like this. So like this I have to consider the sampling and from the systematic data sample. So see the example. So population, so I have a student numbers up to 1 to 60. So since I'm going to sampling interval, what I get is 10. So in between 1 to 10, I'm going to be select the value, random value. So I'm going to select 5 here. So if I'm going to select 5, so this should be the sample of that population. Suppose if I'm going to select 8 here, so then I'm going to get this sample from this population. This kind of sampling what we call as a systematic sampling. And next one is that cluster sample. So cluster sampling is that this is also a method. So when the population is going to be large and then should also be consists of several groups. So normally previous thing also I have population. So in this population also I'm going some group, some characteristic, some grouping is done. But here the cluster sampling means it also be also a method where the population is going to be divided into several groups, so which may be called as a clusters here. So cluster is the thing, so all the members of this cluster is going to have similar characteristics. So suppose this is the population I'm having. So this cluster is going to be created of students of CSC, and this group of cluster is going to be created based on EEE, and this group of customers is going to be created based on EC, like this. So in this method, the cluster is going to be considered as one of the sampling unit. So we are going to select a simple random sample of clusters. So all observation in the selected cluster are to be included in the sample. So smaller the size of sample will be the cluster which should be able to give the better results. So for the example what I'm taking here is that, so in a health survey of the state, so the state is going to be divided into villages, right? So it should be a cluster, and the simple random sample of the villages may be the selected one, so where the information about each and every individual in the selected village can be collected. So like this. So here the population is there. So the population. So these are the people which are belongs to some X village, and these are the people that are belongs to the Y village. So I'm going to group all this as one group. So which will be treated as a cluster. Okay, and so this is the view of this cluster sampling. So how this population is going to be done, and how we're going to be make a group of clusters like this, and the data what I'm going to be considered from each cluster should be one of the sample of this population. So this should be the population of group of clusters. So this is the way of cluster sampling. So cluster sampling means it should be a method where the population is going to be divided into different sizes, and where the size would be of different clusters like. So the cluster should be one of the treated as a sampling unit, and where the observations of selected samples also be a one of the member. So some smaller the size of cluster should be the best result, and then you can also be able to give when compared to the different types of sampling. So the samplings normally of different types, what I said should be, so simple sampling, stratified system, and then clustering. So simple means should be the most efficient way, and then more convenient and easy to implementation of the sampling. And the normally this kind of sampling should be done for the only for the homogeneous data element. And stratified data sampling means, so here the population is divided into several homogeneous groups, what we call it as a stratum. And then when it comes to this cluster data sampling, so the data is going to be divided into clusters where we can able to divide this population as a groups called as a strata. And this strata is going to be divided according some criterion, so like mainly geographical location, age, gender, religion, and then income. So this is the view of this strata. And that means where the sample is going to be drawn from each stratum. And systematic data sampling is the one of the way of arranging the sampling in a systematic order. So normally this one is going to be done through the sampling frame actually. So based on some sample interval is going to be considered. So this is the example what I do. So I'm going to have a committee of n number of students, and this one and total number of students should be 60. So I'm going to be calculate the sampling interval, that means by number of students by sampling size I'm going to be consider. So that should be 10. So in between that I'm going to consider, and should be I'm going to select based on the interval size. Then it should be the systematic sampling. And cluster sampling means, so here the population is going to be divided into groups, what we call as the clusters, and this cluster should be considered as the sampling unit, which is going to also give a best results. And this should be the view of the cluster sampling here. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.